All right, folks, it's Bass Action, back in action. In this video, we're going to look at two concepts. The first concept will be describing intervals of the function that are increasing, decreasing, or constant. And then in the second idea we're going to look at is finding extrema, and we're going to talk about local maxes and mins and absolute maxes and mins and compare those. So let's start here at the top and where we're talking about our increasing, decreasing constant. And the first thing I want us to look at is actually this first part right here that's going to be the same no matter which type of an interval that we're talking about. For all of our intervals, increasing, decreasing, or constant, they're all going to be open intervals. Now, when we are talking about them being open intervals, that means that we will never, and I mean never, we will never use brackets, okay? We will always, for these intervals, we will always use parentheses. The next thing that we're going to note that's going to be the same for all of them is that they are open intervals of x values. So the answers that we write are x values, even though we find them by looking at y values. So we look at a behavior of the y's, but our answer is the x. So let's take a look at that. If we start with, let's say, increasing, let's first just look at the graphs and understand what's happening here. So if I look, let's say, at this first graph, what I can notice as I trace the graph specifically from left to right, as I start to trace my graph, I notice that my graph is going up, okay? Then I notice that it switches and it's now constant, it stays flat, and then it is up again, okay? When I look at my next graph, then I'm going to notice, and I'm tracing from left to right, I notice that I'm going down, and then I switch to going up, and then I switch back as I'm tracing to down, and then I go back up again, okay? The increasing intervals are the ones that when we traced it, we noticed that it was up. And algebraically, what we would say is that we have some value, where f of x, that's a y value, we have some value of x sub 1 that's smaller than x sub 2, meaning the first x value is, the first y value, when we subbed in an x value, is lower than the second, okay? So that's going to be less. So if we said, for example, that 10 was the first x value and 6 was the second x value, f of negative 10 is lower than f of negative 6, okay? For our decreasing intervals, that's going to flip. That's going to be the other way around. F of x sub 1 will be more than f of x sub 2, meaning it's going to be higher than the next number because it's going to be falling. And then our last one, our constants, will be where the graph remains constant or is flat, continuous throughout the interval. Now, when we go to write our answer, if we've pre-identified these increasing and decreasing and constant intervals, we've pre-identified those, then we can answer these questions pretty quickly. So when I want to find this, looking at this graph, I can already see that I do not have any decreasing intervals. So I could immediately just answer this right off the bat and say there are none, okay? On my second graph over here, I can see that there are no constant intervals. So I could answer that question right away as well. And I would always encourage you to pre-identify and color your graphs. It will make things easier for you. For the increasing intervals that I have here, I can see that I have two of them. So I'm going to have an interval, and it's going to be joined by the u, and I'll have a second interval. Now, the first interval, I'm looking at this interval of y values, and it goes from a negative infinity. This arrow tells me it's going to go to negative infinity and is going to stop at an x value of negative 2. It reaches that point here at negative 2. So when I write that first interval, I'll say negative infinity, and it's going to go to the negative 2. And remember, they have to be open, so they have to be parentheses. I'm going to join that with the next interval that starts here at 5, an x value of 5, and will continue also to infinity. And again, they have to be open intervals because at those endpoints where it switches, it's considered kind of a neutral. You can think of it as a neutral spot. We don't know what it's doing. So that would be my increasing intervals. For the constant interval, I can see that it stays flat from an x value of -2 to an x value of a +2. And I'm going to also use parentheses, again, -2 to +2. When I get over here to my next graph, for my increase in intervals, I'm going to look at these two first. This interval goes from a -1 to a 0, because remember, they're x values. So I'm going to say -1 to 0. It's going to join with a new interval that's going to go from an x value of 1 to an x value of 3. So I'm going to say 1 to 3. My decreasing interval, I can see, is going to go from an x value of -3 to an x value of -1, where it's falling. So now I can say -3 to -1. I'm going to join that with the other interval that goes from 0 to 1. So it falls on this interval of x values. Okay, so that's increasing, decreasing, constant. Now, on the extrema, we're looking at maxes and mins. We're going to fill in some blanks here. The first thing is that a max or a min, maxima or minima, okay, these extrema, these max and mins must occur, they have to occur at a single point. Okay, it has to be a single point. In other words, I can't have an interval, okay? An interval cannot be a max or a min, so I can't have a big plateau. It has to be just a single point. Now, a local max and min requires an increasing or decreasing change. So it's important for you to understand that increasing, decreasing idea from above, because you need to look for those when we're looking for local maxes and mins. In other words, they will look like a peak or a valley on the graph. Okay, so they're going to be some type of a peak or a valley. Now, when we go to find absolute max and mins, those do not require a change. Okay, those do not require an increasing or decreasing change. They can just be an endpoint. They can just be a closed endpoint. Of an interval. Those can be considered a max and min. A hole, which I'll show you a hole in a moment. Okay, holes are not allowed on, they are allowed on the interval, okay, but they are not themselves a max or a min. Okay, so if you have a hole at a peak or a valley, or a hole at an endpoint, it cannot be a max or min. And then the max and min are going to be written as the y value. So that'll tell us what the maximum value is, and then we will usually say at whatever x value it occurred. So let's take a look at our graphs here. So I've got some graphs, and we're going to mark them up first. When I look at this, first of all, I see that I have a hole right here. This is what a hole will look like, and this hole looks like it's at a peak. But because it's a hole, we're going to write ourselves a note that a hole cannot be a local max. Actually, it can't be any kind of a max, okay? Local or an absolute max or min, okay? What I can see is this point right here is higher than any other point on the entire graph. So this is a high point, which means it's going to be some type of a maximum, but because it's at an end and not a peak, we are going to call it an absolute. Okay. Then when I look at this point down here, this is the lowest point of the entire graph. This is the lowest spot. It doesn't have a change, so it's not a valley. So this is going to be an absolute min. And what you'll notice on this is that we didn't label anything as a local. So when we go to answer our questions, we would say that there is none. There's no local max. There's also no local min. We did find a high absolute max, and our highest value was at a y value of 3, and it happened when the x was negative 3. Our minimum was, it went as low as negative 2, and it happened when x was 2. So it's implied that you understand that this is a y value and this is an x value. Let's look at our next graph. The first thing that I want you to notice is that when we look at this graph, we have an arrow here that's pointing down. That means that this graph is going to continue to go down, 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 down forever, which means it will never reach an absolute lowest point. There will not be an absolute minimum. So we could actually answer that question right away and say none, okay? Now, I do find some peaks and valleys. So I find this point up here is a peak. It also is the highest point on the graph. So this is going to be both a local and an absolute max, okay? So I can say that I have an absolute max at 4, and it occurs at an x value of 1. I can see it's a local, so I can rewrite that 4 at 1. But then I'm also going to notice that I have another peak right here, okay? So what we're thinking is I can have some PRs or some bests, okay? But I can only have one very best. I can only have one absolute, but I can have many locals, okay? So there will be another one, and we'll list our other peak, and it happens at a y value of 2 and an x value of 3. And then we're going to look for any valleys. Are there any valleys? And there is in fact one. And that valley occurs at a negative 2 at an x value of 2. This endpoint here is lower than this, but remember this arrow already told us that there would not be an absolute minimum, okay? So we'll practice this more as long as you can get comfortable with this, and I've got a whole bunch of practice when you come into class.